Hi guys, in this video we're going to look at what's called the related rates of change, and there's a bit of blurb here which we'll just go through. So sometimes we're given one rate of change and asked to find a related or connected rate of change, and in order to do that we use the chain rule. Now the chain rule is given over here by dy dx is equal to dy du dot du dx, where du is a third variable that we can combine. Notice that the du's here will cancel. We get dy dx is equal to dy dx on the right hand side. We've done this last year. We generally didn't use it in the way that we should have, and we used all of the shortcuts, but it's just handy to know that dy dx is equal to dy du dot du dx, and the fact that this is also in your tables book. So let's have a look at an example. Suppose we are told that the radius of a circle is increasing at 5 centimeters per second, and we want to find the rate of the increase of the area of the circle. Okay, so first of all we can see here that the rate, that's what we're told, increasing at 5 centimeters per second. The s to the minus 1 is per second. So that means that we can say that there is dr dt. Okay, so we now know that there is the rate of change of the radius with respect to time, and that there is dr dt. And it says that we want to find the rate of increase of the area of the circle. Well, the rate of increase, rate is differentiation, and it says the area of the circle, but it doesn't tell us with respect to what. And if it doesn't tell us with respect to anything else, we automatically assume that this is going to be time. So the rate of increase of the area of the circle, that there is, this whole idea is dA dt. Okay, so it says here that R be the radius of the circle and A be its area. Then we are told that the rate of the change of the radius R with respect to time is 5. So we now know that dr dt is equal to 5, which is what I just stated up here. What we want to do though is we want to work out the rate of change of the area. And again, because I said we're not told with anything else, so we have to assume it's with respect to time. We want to find dA dt. We have been given dr dt, okay, so there's dr dt, and now we need to figure out what's going to be the end of the chain rule, the part of the chain rule that's going to make all of this work. So the way to think about it is, what do we need to find, that's what goes here, is equal to what we are given, and that comes from the question, and now we need to figure out what needs to go here. Well, you can see here, dA dt, we've got dr dt, and that means that we need to have, if you look at the chain rule over here, we've got dy dx is equal to dy by some third variable by the third variable over dx. So notice that this third variable makes like a, what we call it, diagonal, and then dy dx on the left must equal dy dx on the right. So our dy dx essentially is dA dt. So what we have here is we have dA, just to put it into underneath the chain rule here, we've got dA dt is equal to, and we've been told one of them is dr dt. Now we've got to figure out the next one, but we need to have an a on the top here, so the next one has to be dA, d something, and notice we have the dt on the bottom here, so now we have dA, we have dt, dA dt, and this variable must be the same, so dr, and that therefore must be dr, otherwise they will not cancel out. So we can see here, hopefully, that we have now dA dt must equal dr dt dot, and we've got dA dr on the other side here. So dA dr. Now, once we have that, we've got to try and find some linkage again. So hopefully we can work out that the linkage that we know here is that the area is equal to pi r squared when it comes to a circle. So the area of a circle is pi r squared, which now means that I can easily find dA dr. Okay, so I'm going to, you can see there's only one variable here on the right hand side here. So I'm going to take dA dr, and that's going to equal, and that's just going to be 2 pi r. Once I have everything I need, I can then start to combine it. So I now know, so I'm just going to go here, that dA dt, so the change in the area with respect to time, is equal to dr dt, okay, multiplied by dA dr, and I'm just going to combine everything that I know. So dA dt is equal to dr dt, and that there comes from the question. We know that dr dt is equal to 5, so that equals 5. And then what we have then is multiplied by, and dA dr is 2 pi r, which means that my rate of change, let's go back up here now, dA dr, so the rate of change of the area with respect to the radius is equal to 5 times 2 pi r, which is 10 pi r. And then if we need to stick a radius in, so I suppose we want to know when the radius is equal to 2, so if the radius is equal to 2, then we know that dA dr is equal to 10 by pi by 2, which will then be equal to 20 pi. Okay, so let's have a look at another example. It says here liquid is poured into an inverted cone, as you can see here, the apex down, at a rate of 3 centimeters cubed per second. The cone has a radius of 20 and a height of 48. Find the rate at which the height of the liquid in the cone is increasing when the height of the liquid above the apex is 36. Okay, so first of all, let's set up, so what do we need, what do we know, etc, etc, etc. So we are trying to find out the rate, find the rate at which the height of the liquid in the cone is increasing when the height of the liquid above the apex is 36. Now, it doesn't say what it's increasing with respects to, so we're trying to find it with respects to time. So we are trying to find, okay, and what we know, and then times by what we need. Okay, that gives us our chain rule. So we are trying to find dH dt. What do we know? Well, we can see here, we've got something here. What we have here is, we have been told that the rate is 3 centimeters cubed per second. So centimeters cubed will tell us that that there is a volume with respect to time. So we know what dV dt is. So we know what dV dt is, which means that we're going to need to find, well, we've got dt and dt on the bottom, so that's fine. We need to have a dH on the top, so that's going to have to be dH there. And the third variable that we've introduced is this dV, so the dV must go under the dH. So this means that we've got to find some linkage for a dH dV here. So we've got to try and find something to do with the volume and the height, because V is volume, H is height. Now, let's have a look here. So let's write down a few things that we know for a cone. We know that the volume is equal to 1/3 pi r squared h. Well, that has h in it, but also has an r in there. So hopefully we should be able to get rid of this r and turn it to h somehow. And the way we're going to do this is by looking at the diagram here. So let's have a look. We've seen this before in one of the previous exercises, where I can start looking at trying to make a pair of similar triangles. So hopefully you can see, if we take the full cone here, you can see that if I take this and make a right angled triangle, that we're going to have a radius of 20 and we're going to have a height of 48. So I'm going to take that out here. So I'm just going to show you on this diagram here. I'm basically doing this and this and this. So what we end up with is this as my red triangle. Okay, I know this is 20. I know that this is 48. And then hopefully you can see there's a smaller triangle in here. I'm just going to do that in blue on the actual video here. So you see here, there's another triangle, and these are similar because those angles are the same, those angles are the same, and those angles are the same. So I'm going to bring out this smaller triangle. And for this one, I don't know what the radius is. It's r, because it's going to change as the liquid changes or as it fills up. The r is going to increase. I don't know what the h is going to be again, because as more liquid goes in, the h is going to increase. That's going to be h. But what I do know is that these are in ratio. So by using similar triangles, I can say that r over h, so r over h is equal to 20 over 48. And I'm going to try and get rid of my r, because I want everything in terms of h, so that I can differentiate dH, dV, or dV, dH. Okay, so I want everything in terms of r. So r is equal to 20h over 48. We can tidy that up a bit. We can say that R is equal to, if we divide everything by 4, I think will work, it'll be 5 over 12h. Okay, now that I have R is equal to 5 over 12h, I'm going to stick it into my volume formula, which will enable us to get rid of the R here, and everything now will be in terms of h, which then means I'll be able to differentiate V with respects to h. So this is the next stage. So V is equal to 1/3, and we're going to get pi by R, and the R, remember, is this bit here, which is 5 over 12h. Okay, so that goes in there, and then we've got that squared, and we've got multiplied by h. So we're going to tidy that up a little bit. If we do that, we get V is equal to 1/3 pi, and 5 over 12 is going to be 25 over 144. And I forgot the h there. The h squared plus it's getting multiplied, so the h squared anyway gets multiplied by the h here, so it's going to be h cubed. So I'll just put that outside there. So that's not too bad. And then what we can do then is, if we wish, we can tidy it up a little bit more and put it as equal to V is equal to 25 over 432 by pi h cubed. Now, we can see here that we need the differential of this, and you can see we need dh dv here, and we've got V here. So what we're going to do is going to work out the differential of dv dh. And if we do that, we get dv dh is equal to, remember to bring down the power, so it's going to be 3 by 25, which is 75 over 432. Let's be pi h squared this time. And that, I think, is going to, it should simplify that. I think it goes to 25. I think 3 goes into both of them, so 25 over 144 pi h squared. Now, that means we have dv dh, but we actually want the h dv, which means that what we're going to have to do is we are going to have to invert this, which means we have to invert this. So when we put it into here, what we're going to end up now is our find, which is dh dt is equal to dv dt. That's the one that we know, and that is 3, and that's going to be multiplied by, and it's dh dv we want, but we have dv dh, so it's going to be multiplied by 144 over 25, and it's going to be pi h squared. And then we can combine them as well, and we'll end up with dh dt is equal to 432 over 25 pi h squared. So just go back over that, what I did. So we've worked out dv dh down here. We want dh dv, so what we need to do is we need to flip this over to get dh dv, which means you need to flip this over, which gives us 144 over 25 pi h squared. Now be careful. What some people do is they forget that the pi h squared is on the top, so when we are actually flipping it, it comes onto the bottom here. Tidy it up, we get 432 over 25 pi h squared. Now we just have to finish off the question. It just states here that find the rate at which the height of the liquid in the cone, which we have here, which is dh dt, is increasing when the height of the liquid above the apex is 36. So all we do now is we stick 36 in here. So at h is equal to 36, dh dt is equal to 432 over 25 pi by 36 squared. We stick it into our calculator and we get 1 over 75 pi, and that's going to be centimetres per second. Okay, so let's have a look at another example. So this one is a rope is attached to the bow of a boat, of a boat, and passes through B, a ring at the edge of the dock. B is 4 meters vertically above A. The boat is pulled in towards the dock by the rope at a rate of 0.1 meters per second. So there's our given, and it's saying telling us that AB is decreasing at the rate of 0.1 meters per second. So that's obviously, if it's decreasing, we're going to get a negative here. Determine how fast the boat is approaching the dock when AB is 5. So I've been told that the rope here is getting pulled in at a rate of 0.1. So this AB here So I'm going to call that x, and hopefully you can see that what we're ending up here with is a right angled triangle. And I'm going to call this here, from here, I'm going to call that y. And what we're going to do is going to set up our chain rule. And again, it's what we want is equal to what we have times what we need. Okay, so what we want here is how fast the boat is approaching the dock. So approach the dock here, that's going to be y. So what we want is dy, we're not told with respect to what, so it's dy dt. What we have here is we're told that it's getting pulled towards the dock at a rate of 0.1, and we know that dx dt, so that's what we have here. So we have dx dt here, which means we need to find, well, according to my chain rule, I need to have dy on the top, and I've got dx as my third variable, so we're going to end up with dy dx here. So we've got to find some linkage between y's and x's, and hopefully you can see this is a right angle triangle, so this is going to be quite nice. So let's take that right angle triangle out, and what we have here is we have 4, we have x, and we have y. And using Pythagoras, what we end up with here is we know that y squared plus 4 squared is equal to x squared. And we want dy dx here, so let's have y squared is equal to x squared minus 16 here, and y is equal to the square root of x squared minus 16. So far so good, nothing too difficult here. Then I'm going to work out what that differential is. So we've got dy dx is equal to, well, before I do that, let's change this to y is equal to x squared minus 16 to the half, because we don't want the square root in there. And we can use the chain rule in order to do this. So remember, for the chain rule, what we do is we bring down the power, we rewrite the bracket, we take one off the power, and then we differentiate the bracket. So bring down the power, that's a half. Rewrite the bracket, x squared minus 16, take one off the power, so that's minus a half, and then what we have to do is differentiate the bracket here. If we differentiate that, it'll go to 2x, and the constant there will disappear, so we've got 2x. We're going to tidy it up a little bit. I'm going to end up with x, and we're going to end up with x squared minus 16 to the power minus a half, and tidy up a bit more. We're going to x on the top, and then we get the square root of x squared minus 16 on the bottom. From here, we're going to put it back into our formula. So dy dt here is equal to dx dt, which is minus 0.1 from here. Yeah, okay, so it's decreasing. Look, so it's decreasing, so it's minus 0.1 multiplied by dy dx, which we've just worked out, which is x over x squared minus 16. That then is equal to, well, minus 0.1x on the top, all over again, x squared minus 16. Now we've been asked to work it out when AB is equal to 5, and AB is the variable x. So dy dt, so at x is equal to 5, dy dt is equal to minus 0.1 by x, which is now 5, over 5 squared minus 16 square rooted. And if you put that into your calculator, you get minus 1/6. And we are done.